as we begin today, I want to review over your 3 trig ratios. What are they, Lana? Sine, cosine, tangent. Joshua, how do we remember what each of those trig ratios is a ratio of? That had no expression. Try again. No. Say it like you mean it. Okay, go ahead. Okay, Lana, show them how to do it. Sokatoa. Okay. However you want to do it. The important thing, though, Josh, is that you're able to spell it. And how do we spell Sokatoa?
S-O-H space C-A-H space T-O-A.
Right. Sokatoa. And helps us remember, class, say it with me, that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And again, the key is to look at the appropriate angle to spot what's opposite. That's always the first thing I find. Where's the opposite? Because you can just go straight across. Hypotenuse should be easy, and adjacent's the other one, the one that's next to. So as you turn in your textbooks to page 540, page 540, at the very top of the page, you're given 2 right triangles, a purple one and a blue one. And make sure you note where the right angle is, first of all. That's important also. But in number 13, you're going to find sine, cosine, and tangent of angle R. I would suggest marking angle R, maybe with a little arc. And then for number 14, finding the sine, cosine, and tangent of angle A. Again, we always would find the sine, cosine, and tangent of just the acute angles. You cannot find them for a right angle, merely acute angles. So if you would, go ahead and work on numbers 13 and 14 there at the top of page 540. And then we'll go over that and we'll get into the rest of our review as we look at a test coming up in lesson 172 on Tuesday. Let's go in full review mode now. This is your last test before the exam, yes. And I was pretty sure that's what you meant.
Well, we both have A's all year.
So in other words, don't blow it on this test and you get out of the exam. Yeah, pretty much.
I have a really high A's.
He's exuding confidence right now. That's good. That's good. It's good to have confidence. Lana lacks confidence. I find your lack of faith disturbing. Number 13, number 14, on page 540 at the top. That was for Scott, in case you forgot what we were doing. Good, Joshua. And Lana just started. Okay, well, Lana, number 13. You marked little angle R. What did you get for the sine of R?
9/41.
Good. Opposite over hypotenuse is 9/41. What about the cosine?
40/41.
Good. Adjacent over hypotenuse is 40/41. And the tangent?
9/40.
9/40. Opposite over adjacent. Good. How about number 14 for angle A, Joshua? What did you get for the sine?
35/37.
Good. 35/37. Opposite over hypotenuse for the cosine?
12/37.
Good. 12/37. Adjacent over hypotenuse. And then for letter C, the tangent? 35/12. Again, that was 35/12 in case you couldn't hear it. Opposite over adjacent. All right, questions on that? Good to go. Again, really not a lot of math to do, just identification. Well, suppose I gave you this triangle here, a very tall, skinny triangle, and I told you that this length here is 34, and I told you this length here is 16. Let's call this right angle C, so that way this is side C, C squared. Let's call this angle A, so this is side A, and we'll call this angle B. Well, in order to find trig ratios, you need to know all three sides, right? But I didn't give you all three sides. How would you find the third side?
Add those and subtract them.
That's how I find an angle. How would I find this third side AC?
Oh, you just take like square both of them.
What do we
and
call
then
that then?
Oh, the Pythagorean theorem.
Pythagorean
Oh.
theorem, of course. So several things I want you to find. First of all, I want you to find side AC. Once you've found side AC, I want you to find the sine of angle A. Then I want you to find the cosine of angle A. Then I want you to find the tangent of angle B, the sine of angle B, and the tangent of angle A. All right, so 6 things to find at your seats. Go ahead and work on this classwork problem now. Okay, Lana, I'll move the lectern for you. Is that better? Okay, now she can be happy again. Find the missing side, and then those 5 trig ratios. And Scott, they are doing this without a calculator, Scott, so put yours away. It's too late, you already found it. Should have mentioned that earlier. Scott's like, I haven't used a calculator this whole time, Mr. Tedeschi. Just saying. Okay, Scott, fine. I'm just picking on you in person, Scott, in case you can't tell. So does Hayden.
And all the guys.
Make you feel good to know you're missed, Scott? I don't know what he said. Okay. How big is side AC class?
30.
30. Good. All right, sine is what over what class?
8 over.
No. In general, sine is what over what?
Opposite over hypotenuse.
Good, opposite over hypotenuse. So as we look at angle A, what is opposite over hypotenuse, class?
8 to 17.
16 to 34, but that will reduce to 8 to 17. Good. Cosine is what over what, class?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So again, looking at angle A, adjacent over hypotenuse,
30 over 34.
30 to 34, which reduces to
15 and 17.
Then we have to change our focus, and now we've got to focus on angle B. And we're looking for the tangent of angle B. Tangent's what over what, class?
Opposite over adjacent.
Opposite over adjacent. So for angle B, opposite over adjacent,
15 to 8.
well,
30
to 16, which reduces to 15 to 8. Still with angle B, looking for the sine again. Sine is what over what?
Opposite over hypotenuse.
Opposite over hypotenuse. So for angle B, opposite over hypotenuse,
30 to 34.
30 to 34, which reduces to
15 to 17.
15 to 17. And then switching back to angle A again, so back up here, tangent's what over what?
Opposite over adjacent.
And what is opposite over adjacent?
16 to 30.
16 to 30, which reduces to
8 to 15.
8 to 15. Good to go on this. Any questions at all on finding a missing side of a triangle using the Pythagorean theorem, or kind of building on that, finding trig ratios for acute angles? All right. Looking in your textbooks then at the Chapter 11 Review C. Let's look at numbers 1 through 8. We'll just go through these orally. You do not have to write the answers down unless you really want to. Number 1, what's the name for a number written inside a radical sign, class?
Radicand.
Good, Joshua, the radicand. The radicand. Number 2, what's the name for the small number that indicates which root is to be taken?
Index.
The index. Good again, Joshua. Lana, feel free to answer. Number 3, what are the 2 requirements for radicals to be like radicals?
Same exponent, same.
Ooh, not same exponent.
Same index, same radicand.
Same index, same radicand. There we go. Number 4, what's the name for roots that come out evenly?
Oh, wait. I forget.
Rational. Wouldn't write that answer down. Write that answer down. If you would, rational. Remember, if it doesn't come out evenly, that's irrational. And those have to be reduced if possible. But rational roots, they just come out evenly. It's great. Kind of on that same note, the whole numbers, 1, 4, 9, 16, 25, they're all examples of what?
Squares.
Perfect squares.
Oh.
Perfect squares. Good. Number 6, what's the name for the longest side of a right triangle?
Hypotenuse.
Hypotenuse.
Oh.
Hypotenuse is the longest side of a right triangle, and it's always across, class, from the right angle. What's the name for the other 2 sides?
Legs.
The legs. And they're the 2 sides that are perpendicular to each other, that form the right angle. Number 7, what states that the square of the hypotenuse of a right triangle is equal to the sum of the squares of its legs?
The Pythagorean.
How do you spell Pythagorean?
Pythagorean.
I'm confused. I have
P-Y-T, so capital P, P-Y-T-H-A-G-O-R-E-A-N, Pythagorean. Pythagorean theorem. Good. How do we spell theorem?
Theorem.
E-M. Theorem, if you will. Theorem. Pythagorean theorem.
I read it out.
Anyway, number 8. What branch of mathematics deals with ratios between sides of triangles? Trigonometry. No fair cheating in writing trig. Trigonometry. Anyway, questions on those?
No.
All right. Numbers 9 through 20 are some rational roots here. Sometimes they're missing the radicand. They've given you the answer. Other times they are missing the solution. So fill in numbers 9 through 20 very quickly at your seats. Do them without looking back.
Yeah, like the first time for surfing it, it didn't like get the wood, so it was just like barely interesting.
Okay. Mine's finished. Thank you. Etc. Just providing my own subtitles. It's okay, Scott, you can't get corona through the camera, so you're fine. Glenn's like, I'm going to test positive for corona like 2 days before exam week starts, so we have to cancel exams again. I don't know if that's going to work. That's not bad. All right, let's see how we did. Number 9, class, the square root of 49 is 7. We should have known that one pretty well. Square root of 121 is?
11.
The cube root of
8.
8 is 2, because 2 cubed is 8. The cube root of 125 is 5, because 5 cubed is 125. The square root of 225 is 15. Number 14, the cube root of x cubed, x. The 3 and 3 cancel, right? Number 15, the square root of 289 is 17. Just had to multiply 17 by itself to figure that one out. Or did anyone have it memorized? You remembered it? Wow, both of you, good. Number 16, the square root of 256? 16, they gave you the answer right there before the radical. Just kidding. Number 17, the cube root of 343. 7. It is 7. So you try a number and see if you can multiply it by itself a couple times.
I think the 19 squared.
Now 19 squared is 361, but again, since you're trying to find the cube root of what, or the cube root of 343 is what, he's like, well, I don't know, maybe it's 19. So you say, well, let's do 19 times 19 times 19. But after just one multiplication, you're already too big, so like, well, it can't be that. In fact, we're nowhere close. In fact, you know that 10 cubed, Joshua, is
100. I mean, 1,000.
1,000. 343 is way smaller, right? So we can't even be at as big as 10. So maybe you're like, well, I remember that the cube root of 125 is 5, right? Cube root of 1,000 would be 10. So it's somewhere between 5 and 10, probably still closer, because this is closer to 125 than 1,000, probably closer to 5, maybe 6, nope, maybe 7. Oh, there it is. So there are different ways you can kind of narrow it down without it just being a total guess. Number 18. What about the cube root of what is 8?
512.
512. And maybe you stumbled upon it while you were trying different numbers, and maybe you tried 8 cubed, and you're like, no, that's not it. And you saw cube root of 512, you're like, oh yeah, I know that. What about number 19, the square root of 324 is 18. I think just forgot to write the 3. Okay, I only heard 24 from you. 324, I heard it from Lana, is correct. You didn't have it, didn't say it, I'm just deaf. And number 20, the cube root of 216? 6. 6 is our answer there. All right, questions on those? Questions on how to figure those out without wasting a whole lot of time? Does that kind of make sense, Josh? Like, you know some of them, and you know this. I kind of make this your benchmark. You know it can't be bigger than 10 if the number is lower than 1,000. So it's kind of game plan around it. Real quick, I want to review something with you before we continue in the review lesson here, and that's this idea of fractional exponents. You'll remember that to take the root of a power, class, you divide the exponent by the index. There we go. So here I'm going to divide the 8 divided by 4. But how do we show division in algebra class? Fraction bar. So we can say this is x to the 8 divided by 4. Now normally we wouldn't waste our time. We do it in our heads. In class we just get
X squared.
X squared, of course. But in some cases it doesn't divide evenly. So in that case we'd have to leave it as a fractional exponent. In class we would say
How many times?
a to the 7
over 5.
fifths. Now, if we were trying to simplify or reduce it, you're right, Josh, we'd say 5 goes into 7 one time with 2 left over, right? But if we were simply trying to write it with fractional exponents, we would just leave the exponent divided by index. What about here, Josh?
And 4 divided by 6.
M to the 4 sixths, right? How would we read that?
M to the 4 6.
Good, M to the 4 sixths. But we wouldn't leave our answer like that. Why not?
Because
It'd be minus a point. Don't you hate minus a point? That would be minus a point. Why? Lana?
You have to reduce it.
You have to reduce
I
the
was
fraction.
gonna say reduce, but like
But not reducing a radical, just reducing a fraction. Josh, what should our answer be?
M to the 2/3.
Good, M to the 2/3. We always reduce fractions even when they are exponents. Coming right here, sometimes it works out like we had here where you could just divide easily. Sometimes we can divide easily, Lana.
5 squared.
5 squared. Of course, we wouldn't leave an answer like this. We would here, because we don't know what x is. We can't really square it. But when you know what the value is, we would usually go ahead and square it and just say 25. And then Joshua, you get the big one. How would I write the 8th root of wx cubed y to the 4th c to the 6th using fractional exponents?
So you don't simplify it?
No, we're not going to. We're just going to write it using fractional exponents.
W to the 1/8 times x to the 3/8 times y to the 1/2
Good. Not 4/8, but 1/2. Excellent.
times z to the 3/4.
And not 6/8, but 3/4. See, that's why I gave you the big one. I knew you'd do a great job with it. Lana, would you have done as well as him? So you knew it?
Yeah.
All right, good, good. All right, excellent. Questions on these? Now, the next section you'll notice as you look at the top of the next page, they say they want you to use fractional exponents, but since all of them divide easily, we don't waste our time with 8/4. We just say 2. We don't waste our time with 6/3. We just say 2. Let's do that. Let's just go straight to the simplified form on numbers 21 to 26. Simplify fully. We don't necessarily need fractional exponents on these because they work out easily. (21 to 26). All right, good. Josh? Lana just started. All right. Gotta take faster drinks of water, Lana. That's all I'm saying. Number 21, class.
23.
23. That's the square root and the square cancel. Number 22, initially, class.
Oh, I did 23.
Number 22, excuse me. Number 22, class. Initially,
4 cubed.
4 cubed, but that becomes. He wasn't done.
I wasn't thinking about that.
64.
64. Good, Lana, helping him out. Number 23, class.
X
X to 8.
X to the 8th. Number 24, initially
20 squared.
20 squared, but that becomes
400.
400. Number 25.
5.
5. The 5th through the 5th cancel. And number 26, Lana.
8 to the
8 to the 8th. Dividing by that 2. Yes, ma'am.
8. What was 24?
24 was 20 squared, which becomes 400.
Yeah.
Because you're dividing 4 divided by the understood 2. Questions on those? All right, quick, easy section there. Yes?
No, I'm just slow.
You just slow getting started even. All right, so you ready to get started? All right, you ready to get started? All right, I'm going to have you practice reducing radicals now in this next section. We're only going to do the odds, 27 to 37. Okay, so 27 to 37, the odd. Remember, if it's a number, we want to factor it up. If it's a letter, we're dividing exponent by index. How many times does this go into that? However many times and however many left. All right? 27 to 37, odd. And good, Joshua's finished. All right, I'm just kidding, I'm just kidding. now I'm thinking a lot. These take a little longer. I have way too much fun at my job. What?
Huh?
Thought you said
I
something.
said that's a fact.
Okay. All right, I thought I heard Glenn mumbling back there. I was like, see me after class for detention. 7th graders don't speak in this room. Just kidding. I really should be more serious. We're at school. We're supposed to be miserable. No laughing aloud. No smiling. Stop it. Right, some of them reduced, some of them came out evenly. Check your answers. Maybe factor into a 64 times 100 to get 8 times 10 or 80. Here, 4 times 21, you can only take the square root of one of them, not both of them, so we have to leave the square root of the 21. Same thing here. You can take the square root of one of them, but not the other one. Here, 16 is 2 to the 4th, isn't it? So the 4th root of 2 to the 4th, they just cancel. Leaves you with 2. Here, 27 is 3 cubed. So the cube root of 3 cubed is just 3, and then 3 goes into 6 2 times. So again, for both of these, they came out evenly, rationally, instead of irrational. And then the last one, 121 times 3, to get 11 times the square root of 3. Did we get all 6 of those correct? Question?
Like, I knew, like, the 4th root of the 16 one, but for some reason I put 4.
Careful. Square root of 16 to be 4. 4 through 16 is 2.
Yeah, and then 27 into the 6, I just, like, second guessed myself or something like that.
Yeah, I actually started to factor at 9 times 3. Like, I was all set. You can actually see where I started to rewrite cube root of 9 times 3. And I was like, whoa. Cube root of 27 is just plain on 3. So it actually threw me off guard just for a minute there myself. Okay, any other questions, comments? All right, go back into the evens now. 28 to 38. The even. Lana won this time. That's a big number. But if I add up the digits, the 9 is kind of right there screaming at me. So I'm going to go with the 9. 9 goes into 72 8 times evenly, nothing left. 9 goes into 9 once. I can take the square root of 9. I can take the square root of 81. And apparently, the square root of 729 is 27. And there we go. Finding it by factoring. Here, there's another 9. But this time, the second factor, I can't take the square root of, so I'll take the square root of 9 and get 3 and leave the square root of 6. On the next one, I mean, there's a 4, obviously. I'm not sure what else there might be. So 4 times 101. Well, there's not another 4 or 9, definitely not 16. 25, 36, of course not. 49, no. 98 would have worked. Yeah, it doesn't factor anymore, so we'll just get 2 times the square root of 101. And looks pretty rough, but there's nothing else you can do with it. Good, got it. Here, the question again is how many times does this go into that? 5 goes into 24 times with nothing left. 5 goes into 10 2 times with nothing left. Perfectly rational. X to the 4th y squared. Good to go there. But the next one, there's an understood 2, which goes into 7 3 times, but this time there is 1b left inside. And there's our answer. And on the last one, now if that were 27, I'd just get a 3, but it's not a 27. So I can't take the cube root, but I can factor it. I can factor 8 times 3 to get a 2, and we're going to leave the cube root of the 3. I'll make sure we remember that index. And then with the letter, we just say, well, 3 goes into 5 one time with 2 left over. And I probably didn't need to leave quite so much space, but you know. Did we get that answer for the last one?
No.
All right, making a correction there.
I didn't think about the letter.
Okay, so you took care of the number, but not the letters.
Yeah.
What about on the previous one? Did you get the b cubed square root of b? Okay, so you did that. It was just this one you forgot about the a. Let me give you one more real quick then. Let's do the cube root of 250 m to the 7th n to the 11th. And making a list of cubes may be helpful, as I've referenced before.
Well, he doesn't have to use spelling unless I do. He has to.
So Joshua, how did you end up factoring your 250? Did you figure it out?
I was gonna do 25 times 10, but that's
That'd be
not
for a
cube.
square root. Yeah. So like I said, this was my suggestion, was make a list of cubes, right? So I just kind of wrote them out. 2 cubed, that's 8. 3 cubed, that's 27. 4 cubed took me a minute. Okay, 64. 5 cubed, think quarters. Okay, that's 125. 6 cubed, 36 times 6. 216. And then pretty much to 250. So the cube should be somewhere in that list.
Maybe 8.
All right, so let's try 250 divided by 8. 8 goes into 25 with
4. Well, 1.
8 goes in, 8 doesn't go into 10 either, does it? So it can't be 8, which by the way, means it can't be 64, because there's an 8 in 64, isn't there?
So 27.
All right, so,
Oh wait, no.
no?
It's 125.
It is 125.
I'm not even done.
And so we should have factored it into,
125 times 2.
and I will say, Joshua, that's the downside of me working this list out, because I guarantee you, if you'd worked the list out, as soon as you wrote a 1, 2, 5, your brain would have clicked 125 times 2. But because I wrote them down and just kind of perused through them, I tried not to emphasize that number, you kind of missed it. So if you'd been working and if you'd made that list, you'd have found it real quick. What do we do from here?
You see how many times 3 can go into the n to the 7.
We can. I would take care of the number first.
Oh, I did that already.
I'm sorry.
The cube root of 125 is 5. And then you just keep the 2.
There we go. All right, now let's take care of the letters.
3 can go into 7 2 times with 1 left over. And 3 can go to it in 11 2 times with 2 left over. Well, okay, 3 times.
3 times.
With 2 left over.
There we go. And there's our answer. Lana, is this what you had? All right, questions on this? We remember how to work these. All right. Let's look down a little bit further here. And numbers 39 to 44, you're trying to simplify, if possible, and then determine are they like radicals. And if so, go ahead and add them. So simplify first, then try to add if you can. And if you can't, just leave what you got. 39 to 44 as we finish out the hour. Remembering that we can only add, what kind of radicals, class? Like or similar radicals. Same index, same radical. Josh was good so far.
Oh, you're only supposed to do.
No, you're doing all of them. You just that section up to 44.
Wait, 7?
Oops. I was just seeing if you were paying attention. Joshua didn't pay attention.
Oh, okay.
How about 10 times the square root of 10?
Okay.
Yeah, 7 plus 3 is 10, not 7.
I didn't even see that.
Okay, so those are good. Did you finish 44 too?
Okay. Alright, keep working, Lana, keep working. Alright. Scott, sorry, I couldn't hear you screaming at the computer when you noticed that. But unless you didn't either, and Lana's the only one who did, in which case that would look very bad on us males if I missed it and Joshua missed it, and you missed it. So hopefully Scott noticed. Represent for us, because we ain't representing. Are you sure you actually got these answers?
Mm-hmm.
Okay. And you didn't actually get 7 times the square root of 10, did you? Like
No.
you really did get 10 square root of 10?
I really just remember.
You're just like, I know I got mine right, and I know Mr. Nadesky got his right, so we're good, Mr. Nadesky. I like your confidence, that's good. All right, well, this one here, you can take the cube root of 8 to get 2, but you can't take the cube root of x. You can take the square root of 4 to get 2, but you can't take the square root of x. So we end up getting 6 times the cube root of x plus 6 times the square root of x, but they don't have the same index. And it doesn't matter that they have the same radicand, they don't have the same index, so you can't add them, so we're done.
I thought it was 12x squared.
Ah, careful. If they were, well, if they were both cube roots of x, then it would be 12 times the cube root of x, but not x squared. If they were both square roots of x, 12 times the square root of x. But again, these don't get mushed together. Does that make sense? So even one, if we had 5 times the square root of x plus 8 times the square root of x, that's 13 times the square root of x, not an x squared. Does that make sense? All right, any other questions on that? And I want to try to address every question I can before that test. That way we can both be on the wall this time. Hey, Josh got on the wall last time, Scott. And
Well, he can't really ever get on the
oh, sure he can. I get his test. I could print it and put it up there. Put a sticker on it and take a picture of it.
That's true.
I could do all of that. If he'd ever have a perfect test, I could put it on the wall, long distance. But
Oh, yeah.
I'm really surprised.
same for you, Lana.
I'm really surprised he's not.
All right. But do we understand this now, though? All right. Look at this next one. 8's not bad, right? 4 times 2a. I can't do anything about the 2 or the a, but I can at least get 2 times the square root of 2a. Wouldn't it be really nice if this had 2a in it? And it does. Class, it's what times 2a?
49.
49 times 2a, which gives us,
7 times the square root of 2a.
which when we add them together gives us?
9 times the square root of 2a.
And there's our answer. And Scott's over there like, Mr. Jasky, I'm just like you. I see 7 squared root of 3 plus 3 squared root of 3, and I get 7 squared root of 3. Or whatever it was. 7 plus 3 is 7, you know? Yeah, just stupid mistakes like I do. All right, and good to go on this one then? And then on the last one, I mean, wouldn't it be great if this came out to a 5? 5 times 15, right?
No.
No,
It is 5 times 15, but
25.
15 doesn't help.
Yeah.
We've got to go with
25 times 3.
Yeah, 25 times 3,
I didn't even.
which gives me 2 times 5 times the square root of 3, which gives me 10 times the square root of 3. That's not going to combine with the 2 square root of 5, so
I just circled the first
we're
answer.
done. Well, we weren't quite done yet because we had to simplify first. It's simplify then add. So yeah, we do want to simplify as much as possible first. All right, questions on the 39 to 44.
Yeah, I did not get the last one.
All right, you kind of assumed 5 times 25?
Yeah.
Careful, that's $1.25, not 75 cents, so careful there. All right, homework for the weekend. Homework for the weekend is to do page 543. Page 543 in the homework section, 1 through 20 all. Page 543, the homework section, numbers 1 through 20 all. Test 11 is coming up in lesson 172. That's Tuesday. Test coming up Tuesday in lesson 172. That'll be over chapter 11. You will not be using a calculator on the test because all the problems can be easily done without one.
Oh.
So there's none of those big crazy numbers, so you won't need a calculator for the test. But did want you to know ahead of time so you didn't expect the calculator and get to the test and freak out because you don't have one. Don't worry, all the numbers are easy. You're going to be fine. But did want to make sure I let you know now so you can begin mentally prepared. All right. Any questions before we close out? Any last words for Scott?
Bye.
Bye. Just kidding. See you, Scott. Have a good weekend. We're taking a 3-day weekend, so you're not going to see us for a while, Scott.